start recording. Did you start? Earlier, we were speaking about DL configuration, which is a method to assign configuration based on a reference molecule glyceraldehyde. Suppose I have to speak about a molecule, I am assigning D-glyceraldehyde, and if I am assigning L-glyceraldehyde, you will understand it by the presence of OH and H. But what if a compound does not have OH and H? Or what if you are not placing it exactly in the Fisher projection where the top priority functional group is at the top? Then you will not be able to communicate with me. I am speaking about a different configuration, you will be speaking about a different configuration. So to clarify this or to make things better, we have a modern method of expressing the concentration. That method of expressing concentration is RS configuration or absolute configuration. So for this we don't need any reference molecules, that is why we are calling it absolute. Whereas DL we need a reference molecule, so we are calling it relative. That is the difference. Okay. Now in RS configuration we are going to use CIP rule, which we have used for nomenclature of geometrical isomers. In EZ nomenclature we have used same CIP rule we are going to use in RS nomenclature possibly. So CIP rule which we spoke in EZ nomenclature, that we are going to make use of it. Now let us say I am taking this molecule. What does this line indicate for this molecule? It is into the plane of the board. What does this line indicate? It is out of the plane of the board. Let me take an example molecule like this. So suppose this blue atom is hydrogen and the pink atom is, let us say, bromine. This violet one is, let us say, COOH, and let us say this is some CH3. Now I have 4 groups attached like this. In these 4 groups, the group hydrogen as is directed into the plane of the board. Is that understood? The plane of the board is like this. Let me take this as the plane of the board. The group hydrogen is into the plane of the board. Bromine is out of the plane of the board. Whereas the COH and CH3 is in the plane of the board. Is that point clear? Now what you all have to look is, when I am taking the molecule like this, I am just making a twist in this direction. I am rotating it from here to here. Now both hydrogen and bromine are out of the plane of the board. Only this carbon and this COH is into the plane of the board, is on the plane of the board. The CH3 goes into the plane of the board. I am twisting it further like this. Now what happens? Imagine this to be the plane of the board. Now the hydrogen and bromine are towards you, and COH and CH3 are away from you. So how would this structure look like? Which are away from you are represented by dashed lines, that is COH group and CH3 group. Which are towards you are represented by solid lines, solid wedge. So this is hydrogen, this is bromine. So this is one more way of representing the same molecule. Now if I am to convert this into Fisher projection, it will be in one line. That is Fisher projection. So that will be this. Is this point clear now about Fisher projection? So that is this group, that is the Fisher projection. Now what you all should do is draw the mirror image of it on your own, then write it like this, then write the Fisher projection of it. You can try that. Before we proceed into it, now I'll assign priorities to all the 4 groups based on CIP rule. So as per CIP rule, out of all these atoms, which atom should get the highest priority? Bromine. Connected atom, first atom should be taken into consideration. Then next, which atom should be given the priority? carbon and carbon both are of equal priority. Now this carbon is connected to oxygen, whereas this carbon is connected to hydrogen. So priority should be given to this carbon, so that is priority 2. Then priority 3 should be given to this, and priority 4 should be given to this. Are the priorities understood as per CAP rule? Say yes or no?
Yes.
Now, let us repeat with this molecule. Now, the priority groups are such that hydrogen is inside, bromine is outside, COH above, CH3 here. Now, what I want to do is, I will twist the molecule in such a way that the least priority group is perfectly directed away from you. Can you see it this way? Hydrogen is the least priority group. I am directing it perfectly away from you. This is the view you should make any molecule. Whenever you are asked to assign RS configuration and a 3D representation is given, see that the least priority group, that is which you have labeled 4, should be completely directed away from you. Once it is directed away from you, look at the remaining groups. So the remaining groups, this was hydrogen. Now you have directed it like this. Now the remaining groups are, this is bromine, this is COH, this is CH3. So this is 1, this is 2, this is 3. Can you see it that way? Is everybody following? 1, 2, 3. Now 1, 2, 3 are in which direction? Clockwise or anti-clockwise? Like 1, 2, 3. Like this. So 1, 2, 3 are like this, which is anti-clockwise. If it is anti-clockwise, assign the configuration as S. S means anti-clockwise. What are you looking at anti-clockwise? The orientation of the remaining 3 groups are anti-clockwise. For that orientation, most importantly you have to do is put the least priority group, which is labeled 4, completely away from the viewer. You are the viewer. So it is completely away from the viewer. Then the remaining 3 groups, if they are clockwise or anti-clockwise, is what you are going to check. If they are anti-clockwise, S. If they are clockwise, it will become R. Now take a minute's time, draw its mirror image first. Then again mentally visualize the hydrogen to be away from you and see if the remaining 3 groups are directed towards you or away from you. Do it now, all of you. Okay, so I asked you to draw the mirror image of the molecule. So let us reset the configuration. Hydrogen is inside, bromine is outside, COH above, methyl like this. The mirror image of this is going to look like this. That is the mirror image. Is everybody agreeing? This is the mirror image. I hope you all can see it this way. These are the mirror images. Okay. Now what we are doing is, we are rotating both of them like this. 2 groups should be outward. 2 groups should be outward. That is the rotation. Now hydrogen and bromine are towards you. Hydrogen and bromine are towards you. Is this clear? Then I am tilting them like this, such that 2 groups are outside and 2 groups are inside. Is that understood now? 2 groups are outside and 2 groups are inside. Now in this rotation, I have assigned priorities already to the groups. So in the priorities to the groups, I want the least priority group to be directed away from you. Right now what group is directed away from you? COOH group is directed away from you. Can you see it? But I want this, which is hydrogen, to be directed away from you. So what am I going to do for that? I am going to change the orientation. I am starting with this molecule. Let us say in this molecule, hydrogen is inside, bromine is outside. I am taking this, I want hydrogen to be perfectly inside. Now can you see hydrogen to be perfectly inside? Previously it was like this, hydrogen inside, bromine outside, these 2 in one plane. Now I want hydrogen only to be inside. I am twisting it like this. Now this is the perfect position where hydrogen is directed away from the viewer. Is that clear? Hydrogen is away from you. Now look at the remaining groups. High priority group is bromine, then COOH, then CH3. How are these two oriented? Clockwise, no? 1, 2, 3. That is clockwise. If they are oriented clockwise, then the configuration I should write it as R. Is that point clear? Now writing the Fisher representation of this. Again I am repeating that. The Fisher representation is hydrogen is inside, bromine is outside. Then what am I doing? Bringing both of them outside. So bromine is to the right, hydrogen is to the left, COH is inward, CH3 is inward. Make all of them in one plane. That will become Fisher projection. Is that point clear? But for writing the configuration of R and S, I have to put hydrogen inside. Then bromine, COH and CH3 clockwise. If they are clockwise, then it is going to become R. So the configuration of R is different from S. Configuration means what? The orientation of the molecules in the 3D space around this central carbon atom. The configuration of R is completely different from configuration of S. R is not superimposable on S, you can check that. So when I try to place one exactly on the other, R is not superimposable on S. See, two groups became superimposable. They are exactly falling on other. Remaining two groups are non-superimposable, they are not falling on each other. So they are non-superimposable, but also at the same time they are mirror images of each other. This is what we are calling them as enantiomers. Non-superimposable but mirror image relationship. So around this carbon, if the configuration is R, around this carbon the configuration is S. This is what is a different configuration. You can assign to multiple carbon atoms like this. If they are chiral, you can communicate as R and S. What is the idea of assigning R and S? If I say R, you should understand it is like this. You should be able to make this model. If I say S, you should be able to make the other model. That is what is R and S. Okay. So if we have a universal communication as R and S based on priorities, everybody will be talking in same terms in terms of concentration. That is the need of R and S. Is that understood? You can assign R and S based on Fisher projection also. How? In Fisher projection, we have a view that if groups on the vertical line, are they directed outward or inward? Inward. Groups that are present on the vertical line are inward. These are vertical lines, right? Groups on the horizontal line are outward. Suppose I am taking bromine, this is some other molecule now. Now I am taking COH group and I am taking CH3. Always for assigning RS configuration, the least priority group which is labeled as 4, the least priority group which is labeled as 4 should be on the vertical line. It should be on the vertical line. Then assign priorities 1, 2, 3. 1, 2, 3 is in clockwise or anti-clockwise? 1, 2, 3 is in clockwise. Then it will become R. What if in the question the Fisher projection is given in such a way such that the least priority group, which is 4, is on the horizontal line? Then what you will do? Again assign priorities as it is 1, 2, 3. Now 1, 2, 3 are in which direction? Anti-clockwise. If it is anti-clockwise, it will be S. But since the lowest priority group is on the horizontal line, change the answer to the opposite. Then it will be R. Are you getting this point? Since the lowest priority group is on the horizontal line, which is not directed away. If it is on the horizontal line like this, it is not directed away from the viewer. To make it direct away from the viewer, you have to change it to this way. So since that is not happening, since it is Fisher projection, once it is on the horizontal line, whatever answer you get, write the opposite of it. That will be the answer. If it is already on the vertical line, whatever you get, that will become the answer. Is it understood in terms of configuration?
Sir, if the hydrogen atom being up or down on the vertical line doesn't matter.
Up or down doesn't matter. If it is up or if it is down, it is still on vertical line, it means it is directed away from you, remaining 3 will work. If it is down also, it is like you are seeing the 3. If it is up also, you are seeing the 3. Because 3 group rotation doesn't do any change in the configuration. Okay, so this is about assigning RS configuration.